My name is Gladys Nyatic, and my research topic is advanced cooling technologies for jet engine. So in that engine, we have 4 major components: the fan, compressor, combustor, and a turbine. And then during operation, for you to get from point A to B, there is a part that really works really hard and is actually responsible for driving the aeroplane, and it's called turbine section. And that turbine section runs really hot during operation, temperatures of 2000 degrees Celsius. And for the parts in that section or in the engine to survive that harsh environment, they need to be continuously cooled. And to make the engine efficient, you need to make the cooling efficient as well, in terms of taking in less air and using it to extract as much heat as possible to cool the parts. And so the research I'm doing is looking at making the cooling efficient. This kind of cooling scheme that I'm looking at is quite complex. So we can't use the conventional numerical analysis approaches. And one of the big questions that we were asking was that, is it possible to devise or to come up with a simpler way of quickly getting results from this cooling scheme? And at the moment, I'm looking at a plastic sample, but obviously we can't use plastic sample in a real engine. And so currently, what we're trying to explore, or what we are asking is it possible then to manufacture a real blade using a real engine material? And if so, what are some of the manufacturing methods we can explore? And then another question is, how is the flow physics and flow structure compared to the conventional cooling technique that is currently being used in the industry? And so just some of these samples will help me get or record flow physics from the experiment. So there is an obvious and direct link to environment, especially. So what we're doing in the lab, and even my work and the work of others in the lab, it's majorly the overarching issue is to get engine to run efficiently, and that means using less fuel and getting more power. And when you use less fuel, you obviously expect less emissions. And so if we design then efficient techniques, especially cooling techniques, then we are sure that we are making the engine efficient and cutting on emissions. So there is a direct impact on environment from the work we do.